Hey guys, today we're going to be finding slope and y-intercept from graphs, but we're also going to be interpreting it. So remember back when we looked at tables, we talked about how the numbers had meaning when we look at real-world context. It's the same as with graphs. So here we have a graph and a table, which both represent the same linear relationship, where the company is selling bottles of vitamin capsules. The graph and the table show this linear relationship between the cost per capsule in cents and the numbers of bottles ordered. So we want to be able to identify the slope and the y-intercept, but also what they mean. And for today's case, we're not going to be looking at the table because our focus is on graphs. So I notice that I don't see a point on the y-axis, but if I zoom in, I think that I can continue it. I see if it goes up halfway and then it goes over 1, then I can continue going up halfway and over 1 right here. And that puts my y-intercept right at 70. Right at 70 cents, which I'm going to leave in 70 because the unit is cost in cents. And what that means is when I have ordered 0 bottles, it still costs me 70 cents. That is that initial value. But I want to know slope. I want to know that cost per bottle. So as y changes and as x changes, I want to know what that is. So if I'm looking from this point, and I'll do a different color so you can see, from this point to this point, and you could use different points, it doesn't matter because they're all points on the same line. But I'm going from 60 down to 50. So because we want to create that right triangle. I'm going from 60 down to 50. So I'm decreasing by 10. So as my y decreases by 10, my x is increasing, and it goes from 2 to 4, so it increased by 2. So that means that I decreased by 2 cents. I decreased by 10 cents as I added 2 bottles, which means if I'm adding 1 bottle, then it's going to be decreasing by 5 cents. So then my slope would be a negative 5 to represent the 5 cents that it decreases the more bottles you buy. So 5 cents, so it decreases 5 cents per bottle. And our 70 cents represents that cost without any bottles. We're going to take a look at one more example. So now we have a swimming pool, and our x-axis shows us number of hours, and our y-axis shows us water added. So basically, here's our pool, and it started at 0 is what I'm seeing, and then they're adding water over the course of a couple hours, and they're recording how much water has been added. Well, to find the slope and the y-intercept, I noticed that it started off at the origin, which means that my y-intercept is 0, but it also means that this is proportional. And that's important. So this is proportional. It contains that point 0, 0. It also means that every time I take a y and put it over an x, it's going to equal the same thing, which we've called direct variation earlier this school year. But for the slope, I think I could make a table. So I see x and y, and I'm just going to pull some points off. And I'm going to find a point that is clean. So this looks clean, and that's 5 hours 12 inches of water have been added. And then the next clean point I can see is at 10, 24 has been added. So to find that change in y compared to the change in x, I see my y changed by an increase of 12. So as y increased by 12, x increased by 5. But I want to know how much y changes for only one increase in x. So I'm just going to find that equivalence. So I'm going to divide by 5, because 5 divided by 5 gives me 1. And then 12 divided by 5. I'm going to use my calculator. And that gives me 2.4. And what this slope tells me, and what this means, is that it's increasing 2.4 inches every hour. So the slope is increasing 2.4 inches every hour. All right, that's all we got for today, guys.